All right, so today we're going to be talking about section 3.5, which is implicit differentiation and logarithms, although we're going to skip the implicit differentiation part. And so we're just going to learn how to take the derivative of logarithm functions, and then we'll get into a little bit with the tangent lines. So let's just start with the basics. So if we let y equal ln of x, we can rearrange that, and we have e to the y equals x. So differentiating this equation implicitly, which again, you don't need to know this, but we'll use it here briefly. So what do we get? So looking at e to the y equals x, let's take the derivative of both sides. So the derivative of e to the y is just e to the y. Now, whenever you have a y in a function that you're taking derivative of, you got to add in a dy dx, and that's part of the implicit differentiation, which again you don't need to know for this section. And then on the other side, the derivative of x is just 1. So you have e to the y times dy dx equals 1. And if we divide both sides by e to the x, we have 1 over e to the x. And, whoops, sorry, that was e to the y, e to the x, e to the y. And then, of course, e to the y is x. So this would equal 1 over x. And so the derivative of ln of x is 1 over x. And so let's look at an example. Now, this example is going to combine a little bit of what we saw in the last section with composite functions. So anytime you have ln of a function, not just x, you got to take the derivative of the function also. So this is just like what we saw in the last section. So we're going to start with 1 over the thing that we're taking the logarithm of. So 1 over x cubed plus 1. And then we're going to multiply that. We're going to multiply that by the derivative of x cubed plus 1. So we come down, oops, that should be y prime. So we come down here, we have 1 over x cubed plus 1 times the derivative of x cubed plus 1. The derivative of x cubed, of course, is 3x squared. The derivative of 1 is 0, and so that is what we have. And then we can write this as a nicer fraction. So we have 3x squared over x cubed plus 1. And so there's our derivative of ln of x cubed plus 1. So now one thing, you can do this a little bit, I don't know if it's more concisely, but it at least looks nicer. We don't have these two separate things. So in general, what we can say is we have the ln, or the derivative d over dx of ln of g of x. So some function g of x, and we're going to take the logarithm of that function and then get the derivative. So we would say 1 over g of x for the derivative of the ln part. And then we got to take the derivative of g of x, which would be g prime. So in general, you can see this from the last example. We have g prime of x on top, and we have g of x on bottom. So they save you a step, keeps things from looking quite as messy when you're starting out. So let's look at the next example. So now we're going to find the derivative of ln of x squared plus 3e to the x. So we can just use this that we saw up here, g prime of x over g of x. So if you like, we can just write x squared. X squared plus 3e to the x prime over x squared plus 3e to the x. We don't have to do anything with the bottom now. And now we can just take the derivative of the top. So of course, the derivative of x squared is 2x. The derivative of 3e to the x is 3e to the x, and leaving bottom the same. And so that is all we do for that one. So this is fairly simple process. We're kind of using some of the things we've learned in previous sections and just kind of building on that. But as far as how complicated these are, they can get more complicated, but they're not harder. We're just kind of doing what we've been doing. And then the main thing is you just have to be careful with making sure that you are taking the derivatives in the correct order and putting them in the right spots and that kind of thing. But it's not super hard once you kind of get the hang of this. All right, so let's look at f of x equals square root of ln of x. And I would advise you whenever you're taking derivatives and you have roots, radicals, that kind of thing, write it with an exponent because we're going to use the power rule. And it's a lot easier if you just have this already written as an exponent rather than a radical. So now f prime of x, we're going to use a power rule. Bring the exponent down, 1/2 ln of x, and then subtract 1 from the exponent. So we have 1/2 minus 1, so that'll be a negative 1/2 exponent. And then we have to take the derivative of ln of x, and the derivative of ln of x is 1/x. Now let's simplify this. So the negative exponent is going to go on the bottom. So we have 2, we also have an x on the bottom there, 2x with the square root of ln of x. All of that is under 1. All right. Another example. And we have a very similar example. Y equals ln of x quantity to the 5th. So we're going to do the same thing that we did on number 3. So we'll bring the 5 down. And now this is going to become ln of x to the 4th. And then we have to take the derivative of ln of x, which is 1/x again. And then just writing this more concisely, we have 5 ln of x to the 4th over x. All right, so now this one, again, looks like a fairly complicated function, but it's not too hard. Just take it piece by piece. So differentiate this one. So ln of x plus 1 squared. So we're going to bring the 2 down, and then we'll have ln of x plus 1, subtract 1 from the exponent. So now the exponent is just 1. And then we have to take the derivative of ln of x plus 1. And so the derivative of ln of x is just 1/x, of course. Derivative of 1 is 0. And now we'll do the same thing with the other part. So bring the 2 down, e to the x plus 1. Now the exponent is 1. And then take the derivative of e to the x plus 1, which is just e to the x. Right. And you could, we can simplify this a little bit. And you could factor out a 2. I don't think that's necessary. It doesn't make it any neater or anything like that. So let's just move that e to the x over to that side and have it like that. Of course, you probably distribute the 2 to the x if you wanted, or but it doesn't matter. Once we get to this part, that's where we need to be. All right, so now number 6, we are going to use the quotient rule. And so the quotient rule, if you remember, let's see if we can write this over here. So the derivative of, this is u of x over v of x. We have the bottom times the derivative of the top minus the top let's do this with the u's so we can distinguish u's. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And so that's a formula you're going to use a lot, which you may have figured out. And so it's important that you memorize it. However, usually whenever I was in this class, or any calculus class where you had to know this, I would always say the formula in my head every time I write it, because one like this where it's easy to forget which one comes first, which one do you leave alone, and which one do you take the derivative of first, and vice versa. So say it however you need to say it. You say it that way in your head every time you write it, and so then you'll more easily remember it. All right, so of course in this one, the u function for the formula is ln of u. The v function is 1 plus ln of 2u. I guess we need the, I may have forgotten something on that. No, I didn't. I just put an extra parentheses. That's okay. So we don't really need the extra parentheses on the bottom. All right, so we have the bottom. Oops, let's try it again. Bottom times the derivative of the top, which is 1 over u, minus the top times the derivative of the bottom. And so the derivative of 1 is 0. And then the derivative of ln of 2u, and you might notice this once you do a few of these, but ln of 2u. So let's work through this. We have 1 over 2u times the derivative of 2u, which is 2. And so then the 2's cancel out. And so it doesn't matter, anytime you have ln of some constant times u, the derivative is 1 over u, because you have 1 over whatever that is, and then the derivative of that, which is the same as the constant, and the constants will always cancel out. So it doesn't save you much time, but it might save you a few seconds if you realize that without having to work through it. And then all this is over 1 plus ln of 2u squared. And so now it's just a matter of simplifying all of this. So let's see, 1 over u plus, now this one, let's go ahead and do 1 over u. We're distributing 1 over u. But now ln of 2u is ln of 2 plus ln of u. And this will come in handy up here. And then we have the minus, and then 1 over 2u times 2, of course, is 1 over u. So this is, whoops, close that parentheses. Whoops, I forgot the u. ln of u, parentheses, minus 1 over u, ln of u. And now all of this is over the 1 plus ln 2u squared. All right. So now let's combine some of our like terms. We could have done this a little bit more efficiently, but that's okay. 1 over u plus 1 over u ln 2. And now notice we have 1 over u times ln of u minus 1 over u times ln of u. So those are going to cancel out. So this is all we have on top now. And then all over our bottom here. And let's factor out the 1 over u is 1 plus ln of 2 over u is going to go on bottom, 1 plus ln 2u squared. Okay. So this one, I mean, if you just look at that, it looks pretty complicated, but it's pretty much just a matter of following this formula here and then simplifying. And so a lot of times students tend to have trouble, maybe not trouble, but you get careless with the algebra part. So once we get this, the rest is just algebra. It's just combining like terms, rearranging things, putting things on the bottom where it should be, that kind of thing. But you gotta be careful with both because you know, you can make a mistake anywhere and it's a mistake. So you gotta be careful with both. All right. So number 7. So now we're going to get the first and the second derivative, which is no big deal. But this time we're going to use the product rule. So if you remember the derivative of products, so we have a u function times a v function. And it's going to be u times the derivative of v plus v times the derivative of v. That one's probably a little bit easier to remember because you're adding, so it doesn't really matter what order you do it in. You just take the derivative of one while you hold the other constant and then switch. So that was a little bit easier than the quotient rule, but you got to know them both. You're going to use them both a lot. All right, so f prime, we're going to take the derivative, or we'll follow the formula there. So hold e to the x, we're going to take the derivative of ln of x plus now hold ln of x and take the derivative of e to the x. And not too much to simplify here. We can just write that like that if we want. Actually, what we could do, let's just factor out the e to the x. That's all we'll do. So factor out e to the x, and then we have 1 over x plus ln of x. All right, so that's our first derivative. And now we have a second derivative. And so now we can use the product rule again. So e to the x is still the first function, and then 1 over x plus ln of x is the other function. So let's just do, let's put this at the bottom. May not have enough room over there. So f double prime. So we're going to hold the first one, take the derivative of the second one. So 1 over x, and you could, until you get used to this, 1 over x is x to the negative 1, and then use the power rule. So we're going to bring that down, negative x over, or raised to the negative 2. And so the derivative of that would be negative 1 over x squared. So until you get used to that, it may, better to take an extra step than to try to shortcut it and make a mistake. I would suggest until you're very comfortable with it, any time an x is in the denominator like that, write it with the negative exponent and then take the derivative, and then you can convert it back. So that's what we did here. Plus 1 over x. And then we're going to have plus 1 over x plus ln of x. We're going to hold that one the same, and then take the derivative of e to the x, which is just e to the x. Now it's just a matter of simplifying this. And so we have e to the x in both. So let's just factor that out. We have negative 1 over x squared plus 1 over x plus 1 over x plus ln of x. And so then the only thing we have to do is combine these two. So 1 over x and 1 over x. We have e to the x, negative 1 over x squared plus 2 over x plus ln of x. And there is our second derivative. All right, and then the last thing is we're going to find the tangent line. And so this is not super complicated. The most important to remember, what do you need with the tangent line? And tangent line is just the y equals mx plus b linear equation. So we need to find the slope and we need to find the y-intercept. So of course the slope, and pretty much with the second test, any problem that you have, you're going to take the derivative. If you're not taking the derivative, you better be pretty sure that you don't need to take the derivative, because almost all the problems you'll be doing that. So the derivative is going to be the slope. And so let's do that. And remember from first couple of examples that we did, we can just say x squared minus 3 prime over x squared minus 3 for the derivative. So the derivative of x squared minus 3 is just 2x, and then over x squared minus 3. And you gotta be a little bit careful. Don't be tempted. Don't get this one mixed up with the quotient rule and want to square that. You're not squaring it because it's not in the denominator to begin with. So you don't have a quotient here. You have the derivative over the original function, and you're simplifying that. Just be a little bit careful of that because it can be easy to see it on the bottom and then you think, I gotta square it. So, all right. So now we need to find the slope at 0.20. So we're going to plug in 2 for the x. So we have 2 times 2. 2 times 2 over 2 squared minus 3. So that gives us 4 on the top, 4 minus 3, which is 1 on the bottom. So the slope is 4. So we have y equals mx plus b. That's what we need to find. Our slope is 4. So this is 4x plus b. So now how do we find the b? Find the b by plugging in the point that we're given. So the 2, 0. So we have 0 is, still going to use this thing. 0 equals 4 times 2 plus b. So all we're doing is we're plugging in 2 is x and 0 is y, and then we can solve for b. Of course, b is going to be -8. And so our equation of the tangent line is 4x minus 8. All right, and then we'll do it. So get you next time.